Hi, everybody. My name is Michael Zornick, and welcome back to the Code Show. Today, we're going to do kind of an out of series episode, talking a little bit about properties, specifically advanced use of Swift properties. This came up during an actual event we host here in Philadelphia called Side Project Saturday. It's part of our Cocoa Heads chapter. And at this meeting, I was approached by an individual and they had a question about a lazy property and why this one lazy property was working and why this other one was not. And we started to kind of look into it and we eventually solved the problem. Um, but it kind of was this reminder, realization that when you're dealing with Swift properties, specifically this pattern of lazy properties, um, with closures, that there's a lot of ideas compacted into a very small amount of lines of code, and it's very easy to kind of let it have it not sink in to what's going on. And so I thought I would take some time here to walk us through a playground, talk a little bit about properties and what they do, and how you can use them in your own work. So, in its simplest form, a property is to be considered a constant or variable that is assigned to an instance of a given type. So, the best way to kind of work that through is, of course, demo. So, I'm going to create a class called person, and that class by itself has no properties. So, we're going to add our first one, which is going to be a name. I'll say let name, and I'll say string, basically defining that this is going to have a property of type with a name, no name, and the value that's going to be stored in this property is of type string. Now, because we are using the let command, the idea is that this name is going to be assigned and never changed. If you use the var command or var keyword, then the name can change over time with different values. Now, we're getting a complaint here from our playground that says person has no initializers. We'll fix that. We're going to flip it back to let. We're not going to let them change their name. And we'll create an initializer which accepts a name. And I'm going to say self name equals name. And the only thing to really talk about here is that, of course, when you're working with properties in Swift, you generally tend to just call them by their names. The self.name is to handle the problem of confusion because you have this collision. And so if without the declaration of self, there's nothing to tell the compiler, are you referring to the argument called name or the property called name? So we'll add self.name in this case. Now, in Swift, you typically just use the name. You only use self when you're kind of working out the confusion parts. If you're an old Objective C programmer, or if you see a lot of Objective C code, you'll see self all over the place. That is more of an Objective C thing, and in Swift, you kind of tend to avoid that. The next property topic that I want to mention is default values. So you can have a property called likes ice cream, and we'll make this of type bool. Now, if you'd like, you can just default this to a value, so you can say true, and every instance you create will just automatically get the value of true. Because we're defining a default value here, you can in fact actually drop the bool declaration. The compiler will figure out that it's a bool type based off of type inference. And now if we create, a person, and we'll call Amy, and let's say Amy does not like ice cream, you can kind of change that on the fly. But if you create another person, they'll just automatically. Well, here I'll show you. So if we do a dot likes ice cream, by default it'll be true, and then we can define to be false. And then if we ask it again, what is the value for likes ice cream? Now it'll be false. The next property behavior I'd like to talk about is the lazy property. Lazy properties are particularly helpful for when you're dealing with a property that is expensive to create, or needs data after initialization. As an example, just as a point of example, let's say you want to create a date formatter here. You could say this. You could just say actually equals date formatter. And one of the problems with this, as it stands right now, is that every time you create a person, it's going to create an instance of date formatter, and it doesn't matter that you didn't even use the date formatter; it's still going to create it, which is kind of expensive from a memory and CPU standpoint. And so one of the things you can do is to kind of keyword lazy in front of this, and it will create it only when the user actually asks for it. Now, when you do add the lazy keyword, you'll see this compiler warning, lazy cannot be used on a let. That makes sense because it inherently has to kind of mutate the property during the runtime. So you do have to change it to a var. However, you do not have to change the type. So the type is still going to be, if we look at the inference here, it's still going to be date formatter. So it's not an optional date formatter. It's still of type date formatter. But you still have to put var there because it's going to kind of swap during the runtime. So in addition to stored properties, there's this concept of computed properties. And that is a tool in which gives you the ability to create a property, but then define the getter and setter behavior. So let's, just as another point of example, we'll create a property called info, and it'll be of type string. And if you would like, you can create a computed property by defining the get and set behavior right here. You could say, you could allow people to pass in a new string, and maybe you would do some kind of computation based off that before you actually stored it in info. And similarly, when they asked for info, you could do something special. It's very, computer properties are common. However, I would say in most of my work, you typically only implement the get side of things. And so when you're doing that, you can actually just, you don't skip the get and set, just put in one implementation here, and it'll assume to be the get behavior for this property. For info, in this case, we want it to be kind of a descriptive line of text about the person. And so what I would like it to be is kind of like their name, and then if they like ice cream or not. So we'll say let ice cream check. So we're going to assign a string based off of the Boolean value of likes ice cream. So we'll say likes ice cream, and if that's true, we'll say yes. If that's false, we'll say no. And then we're going to return a string, and in that string, we'll include their name, and we'll include the ice cream check. All right, so our next concept, I just want to make a little bit of space here, is going to talk about closures. So if you've been in Swift for a little while, you probably are aware that closures are basically a non-named function. It's a chunk of code that can take in arguments and produce output. And you can assign this chunk of code to a variable. You can pass it into functions. You can do all kinds of fun stuff with them. And so in the case here, we'll do something with a really shorthand where we'll just say let C equal hello. And this is an extremely shorthand closure. But you can see, the C variable is now storing a function of type parentheses into string, which basically means it's a function that takes no arguments and produces a string. Now, in addition to the closure here, you can create something which we call a closure. Okay, I want to make sure I got the syntax right from what I'm about to do. So what I'm about to do is what we call a closure call. So now I will come in here and I'll say let message equal, and I'll just say goodbye. And so this is basically exactly what we have above. You can see it'll be the same return type. But if we add two little parentheses to the end, this becomes a closure call, which basically means the message now, and if I do print message, we'll be able to see what's inside of message. And inside of message is the string goodbye. So now, in addition to assigning a closure to a variable, we can assign a closure call to a variable, and that'll basically say, execute the closure, and whatever the closure returns, give that value to the variable that we're doing the assignment for. Now, this can be really helpful for the properties in classes. It gives us a way to kind of create properties that are dynamically created with closures, but only execute one time, similarly to kind of like the lazy style, where things are only done once. So let's see how this works inside of our class structure. All right, to make this work, what we're going to do is we're going to create a new class called Meetup. And Meetup is going to have a property called members. And members is going to be an array of the person type. And this is where we're going to get some fancy stuff. So what we're going to do is assign a default value, which is a closure call. So we'll say equals, and this is going to be a closure. And then we'll add the parentheses to make it a closure call. Now, inside of this closure, we're just going to do something really simple. We're just going to create a static list of person objects. Obviously, in a production system, you're probably going to do something more interesting, but for the sake of demo, we'll just keep it really simple. So we got Mike and Jane attending our meetup, and if you want to access them, you would say let m equal meetup, and we can do m dot members, and you can grab the first member, which should be Mike. Well, you could do dot name, and that'll be Mike. But you could also just do the dot zero, which will show you the address space. Oh no! All right, had a bit of an Xcode crash there, so just gonna jump back in, and so we created an instance of Meetup by let m equal Meetup, and then we start to inspect the members property. So we're basically asking for the index 0 of members twice. Now, to get this to work like I want to, I actually am going to do something that I forgot to do. I am going to subclass these with NSObject, and you'll see why I do that in 1 second. So now you can see that the instances we get back for person are basically the same object. So we see the memory space here in the sidebar. So you can see this one ends in 6980, 6980. Whereas if you were to change this to just a calculated or a computed property, let this rerun. Notice now that because this is a computed property, these are going to get changed every time. So every time you ask for the members, property, it's going to generate a brand new array every time. So depending on the behavior you're looking for, you definitely want to be careful about these things. So I'm going to revert it back to a closure call. All right, we have one more thing I want to do before we finish this up, and that is to talk about capture lists. So let's add another closure call property to our meetup. Let's say we're going to have a roll call property, which returns string, and we're going to assign it with a closure call. And inside of this closure call, we're going to generate the string that we want to return. And to do that, basically, I want to use the members property above. So I'm going to say self.members. And the way I'm going to do this is I'm going to use the reduce function. No love for the autocomplete. All right. So I'm going to type reduce. We'll do this manually. Ice cream list. So this is going to be our initial value, and then we are going to give it a closure that's going to accept current results and a person, and then it's going to return a string. A little more room. And inside of this, we're going to return the current result plus the person.info, and then we're going to add a new line to the end of the list. So now coming back to the complaint of Xcode, where it says value of type meetup, meetup to the chaining of functions of accepting meetup, blah 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 blah, has no members. The reasoning for this is because these are defined with closure calls, and because they are not using the keyword lazy, it has to initialize it during initialization. And so the way to fix this is we will add the lazy keyword, and because we use the lazy keyword, that'll allow us to reference self in our closure call, and that way we can access our own properties to kind of build our dynamic response, whatever that's going to be. All right, so now that we got that working, let me just fix my syntax bug there. And what are you complaining about? Oh, your string is messed up. Cool. So we're almost done here. Now, because we made this lazy, we can now reference self, but this introduces a problem. Because roll call is going to capture, this closure, it's going to retain self, and because meetup is going to retain the roll call, you end up with this circular dependency problem, basically a retain loop, and if you don't handle it appropriately, you end up with a memory leak. So the way to fix this is we want to reference self inside of the closure, but we don't actually want to take ownership of it. And so the way you do this is with a capture list. So inside of the closure, we can say unowned self, and then we'll just say in. And with this capture list, the self reference here is not going to be captured. It's just going to be a reference. Now, the keyword unowned, the alternative you could use here would be weak. And if you do use weak, then that'll require you to update your code to actually treat self as a weak reference, which would be like with a question mark optional chaining or handling with it other optional, tools. But we don't want that. We're gonna keep it unowned. And the thought process there is that because self is inherently owns this property, there's no way self will ever be nil. It's always going to be pointing to itself. If the meetup ever gets destroyed, then this closure has already been destroyed. And so that's why unowned can be particularly nice here. Plus, because it's unowned, you of course don't have to, handle the optional stuff there. Now, that said, when you're dealing with a closure that's part of like a network request or some other thing, using weak there is much more applicable. Of course, so the basic ruling is that weak versus unowned kind of depends on the ownership model of like who owns what, and so keep that in mind when you're working with it. All right, so we've got roll call producing this ice cream list, and so let's just get a look at what that looks like. We'll come to our meetup, and we'll say roll call, and roll call will generate our little ice cream list here. Which can we make this bigger? No, let's print roll call so we get to see what it looks like in the console. So there's our roll call list, ice cream list, Mike yes, Jane yes. Of course, because persons are just created with, those are the default values. But of course, if you had an array that actually had no, you would see no there as well. But cool. I think that's all I really want to talk about today. As I said, there's a lot of little ideas here that are kind of compounded on top of each other to produce, what we're going to be using here. But this is, if you look at this class meetup, these are very common ideas where you see, dynamic things created for properties, and capturing self here, that can be a memory problem that a lot of people run into. So definitely worth watching the show, hopefully understanding what's going on. If you need a reference, I'll have a link to Apple's stored properties page and closure page. They go over a lot of this as well. But yeah, hopefully you learned something. If you guys have any questions or feedback, I'd love to hear it. And thanks for watching. Bye-bye.